Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In lecture number 1 to 5, we have discussed Laplace transform of some standard functions, and we have derived the formulas for Laplace transform of those functions. We have derived the formula for Laplace transform of sine function, cosine function, Laplace transform of exponential function, and Laplace transform of power function. And we also know that Laplace transform is linear. So using those things which we have done up to lecture number 5, we have discussed Laplace transform of some elementary functions, and we have discussed linearity property also. So using linearity property with all those formulas, we can find out Laplace transform of some functions. So we are going to discuss this question on finding Laplace transform of different functions. So first one is we have to find Laplace transform of the function 2 sin 3t plus cos 3t. So for this we must be familiar with the formulas of Laplace transform of sin 80 and cos 80, and we know that Laplace transform of sin 80 is a divided by s square plus a square, and Laplace transform of cos 80 is s divided by s square plus a square. So using these two formulas with linearity property, we can easily find out Laplace transform of this function 2 sin 3t plus cos 3t. Laplace transform of this function is equal to 2 times Laplace transform of sin 3t plus Laplace transform of cos 3t. This we can write using linearity property of Laplace transform. And Laplace transform of sin 3t is given by this formula, and if we compare sin 3t with sin 80, value of a is 3. So in this formula we will consider a equal to 3, and we have Laplace transform of sin 3t equal to 3 divided by s square plus 3 square. And the same thing here, Laplace transform of cos 80 is s divided by s square plus a square. Here value of a is 3, so s square plus 3 square, this is s. And we can simplify this if we observe denominator is same, s square plus 3 square, that is s square plus 9, and this we can combine 2 into 3, 6 plus s. So this is the Laplace transform of given function 2 sin 3t plus cos 3t has Laplace transform 6 plus s divided by s square plus 9. Similarly, we can do this one also. For this we must be familiar with the formulas of exponential function. Laplace transform of exponential function is 1 divided by s minus coefficient of t, which is a, and Laplace transform of cos hyperbolic at is s divided by s square minus a square. So you must have these formulas in your mind, otherwise you cannot find out Laplace transform of this function. And if you are going by definition, then that is going to be lengthy. So we are not going to find out Laplace transform of every function using definition. We will use the Laplace transform formulas which we have derived up to lecture number 5, and using those formulas we can find out Laplace transform of this type of linear combination of those functions. Here this function is linear combination of e raised to 2t and cos hyperbolic 4t, and by linearity property this is equal to 4 times Laplace transform of e raised to 2t plus 3 times Laplace transform of cos hyperbolic 4t. And now using the formula of exponential function, we know that Laplace transform of e raised to at is 1 divided by s minus a. Here value of a is 2. Therefore, Laplace transform of e raised to 2t is 1 divided by s minus 2 plus 3 times Laplace transform of cos hyperbolic at is s upon s square minus a square, and we can compare value of a here is 4, and therefore Laplace transform of cos hyperbolic at is s divided by s square minus 4 square. And now we can rewrite all these things. This is 4 divided by s minus 2 plus 3s divided by s square minus 16. If we wish, we can take LCM. Denominator is s minus 2 into s square minus 16, and this 4 we have to multiply with s square minus 16, and this 3s will be multiplied by s minus 2, and we can simplify here. Here this is as it is, s minus 2 times s square minus 16, and this is 4s square. 4 is multiplied with s square, and 16 into 4, that is minus 64, plus 3s into s, that is 3s square, minus 3s into 2, that is 6s, and this is equal to 4s square plus 3s square, that is 7s square, minus 6s minus 64 divided by s minus 2 times s square minus 16. So this is very easy. We are just applying linearity property here, and we are applying the formula of this Laplace transform of these two functions, exponential and cos hyperbolic function. Third function is cos square 3t. So we have the formula for Laplace transform of cos at. We know that Laplace transform of cos at is s divided by s square plus a square, but we don't have the formula for Laplace transform of square of cosine function. So the idea is we are converting this function into that function whose formula is known to us. For that we will use this formula from trigonometry. We know that cos square theta can be written as 1 plus cosine of 2 theta divided by 2. If we have theta here, here angle is doubled. If there is theta, here we write 2 theta. So we can rewrite this function as 1 plus cos, here angle is 3t, that we have to double, that is 2 times 3t divided by 2. So this is 1 plus cos 6t divided by 2. We don't know what will be the Laplace transform of this cos square function. Therefore we are converting this function cos square into those functions whose formulas are known to us, and because cos square 3t equal to this, therefore Laplace transform of cos square 3t is equal to Laplace transform of 1 plus cos 6t divided by 2, and using linearity property I can take 1 by 2 outside, and here I can rewrite this as Laplace transform of 1 plus cos 6t equal to Laplace transform of 1 plus Laplace transform of cos 6t, and Laplace transform of 1 is 1 divided by s. Laplace transform of cos 6t is s divided by s square plus 6 square, and this we can simplify. 1 by 2 times 1 by s plus s divided by s square plus 36, and if we wish we can simplify further. We take LCM as s times s square plus 36, and here this 1 is multiplied by s square plus 36, and this s is multiplied by this s, that is going to be 2s square. Therefore this we can rewrite as 2s square plus 36, s square plus s square is 2s square, s times s square plus 36, and this 2 we can cancel out, and we are left with s square plus 18 divided by s times s square plus 36. So in this way we can decide Laplace transform of some another functions whose formulas are not known to us. Suppose instead of cos square 3t we have sin square 3t, then we will use this formula. We know that sin square theta is given by 1 minus cos 2 theta divided by 2, and theta is 3 into t. Therefore this is 1 minus cos 6t divided by 2. So if you want to find out Laplace transform of sin square function, you can convert it into cosine function and constant function in this way, and then you can find out Laplace transform of sin square 3t as we have done this one. So in this way we can find out Laplace transform of some functions which are linear combination of those functions whose formulas for Laplace transforms we have discussed up to lecture number 5. So this is all about this session. In next session we will discuss some more problems of this type. Thank you.